All right, everyone, welcome back. This is part 2 of lesson 6.6. Now we're going to be looking at something called exponential decay. It's just a term that we apply to exponential functions that are decreasing usually over time. Okay, so like here's a good example. Science lab has 400 kilograms of a particular isotope in storage. This isotope loses 3% of its mass every day through radioactive decay. How many kilograms of the isotope will be left over after a week? So it says Q of T is going to equal the quantity in T. This should say days, not years. So let's fix that. Okay. So QT, what do we have here? So Q of T is going to equal, well, what's our original amount? Original amount is 400 kilograms. And then we want to multiply, okay, what's happening to it? It's losing 3% per day. Now, that means we don't want to multiply this by 3% because then we would actually be increasing it by that amount. We'd be increasing it by 3%. So think about, what is 3% taken off of 100? That's 0.97 or 97%. So that means we are, and that's going to be over T days. So that means we are multiplying by 0.97 each and every day, which means it's going to go down over the course of several days. So if we were to put in our values, at 0 days, we're going to have the 400 kilograms, the original starting amount. And then we could have, 1 day, 2 days, 3 days, 4 days, 5 days. Okay? After 1 day, it's going to go down to about 388 kilograms, then down to 376. Then down to 365, and then to 354, and then down to 343, okay? And then if we want to graph this, it's kind of hard to see these numbers, but they go up by tens. Like right here, this is 100, okay? And then right here, I believe, is 200, and then we have about 300, there's 400, okay? So now when we're graphing this, we know that it starts at about 400, and then it's decreasing each and every single day. So, 1 day, it's somewhere around there. 2 days, it's at 376. So we can kind of see, roughly how this function is decreasing. So now let's talk about its behavior. So this time, as x approaches negative infinity, y is actually going up in that direction. It increases, it's going towards infinity. And then as x approaches positive infinity, y is going to slowly approach 0. Remember, it's never going to actually touch 0. It's just going to approach it. It's the asymptote. Okay, it's going towards it. So now our domain is negative infinity, less than x, and x is less than positive infinity. Okay, and the range is a little different as well. If we look at the range of this, well, we really can't. I mean, if we're using this example, they started with 400 kilograms. So we know that the range is going to, y is going to be always greater than 0 to some extent, but it's going to be less than 400, okay? Because it's never, if we started with 400, I know I showed the line going down, but really that's where we started, was with 400. So that's our original amount. And then the question asks, how many kilograms will be left after a week? Well, how many days are in a week? 7. So we would just plug 7 in here, and in 7 days, we're going to get about 323 kilograms, okay, rounding it off, all right? Next problem says here, the value of a boat is depreciating at a rate of 9% per year. Depreciating means it's becoming worth less and less money. Okay, that's what happens to things like cars and boats. They depreciate. That's why they're not very good investments. Whereas typically things like houses, a depreciate, which means they typically go up in value. So it kind of gives you an indication as to what types of things you should spend your money on, things that are going to hopefully go up rather than down. But this one's going down by 9% per year. In 2006, the boat was worth $17,800. Find the value of the boat in 2012. Enter the exponential decay function for this situation. So value in T years. So V of T, in this case, could be, well, we're starting at $1,700 or $17,800 times. Let's see, it's going down by 9% per year. That means 0.91 is what we want to actually multiply by. If we take 1 and multiply 9%, 0.09, we get 0.91, and it's going to be over T years, okay? And so if we're making a graph, we can show that up here we are starting at 17,800, and this is starting in 2006, so that's really what this is. This is 06. We go 07, 08, 09, 10, 11, 12, right? So we can do 07, 08, 09, 10, 11, and we can go to 12. That's really where we want to be, and we can see that this line is going to start to depreciate at some value. And let's talk about the behavior here. As x approaches negative infinity this way, y is approaching infinity. It's going that direction. As x approaches positive infinity, y is approaching 0. So our domain is negative infinity is less than x, and x is less than positive infinity. Okay? And then y is technically right this way. Y is greater than 0. And then I guess we could say that it's less than infinity, because this boat could have existed before the year 2006 and maybe depreciated. We don't know when it appeared, so we just have to go infinitely in that direction. And then if we plug in our numbers, in 2012, which means 1, 2, 3, 4, 5, 6 years, 2012, it should be at roughly $10,108, and that would be this point here. So we're just going to make a line. We're going to call that $10,108 for the value of y when x is at the year 2012, or 6 years from when we started actually paying attention to the function and where it's headed.